So I'm going to go ahead and get started. I think that we have a good number of participants right now, and I don't want to waste anyone's time. I also noticed some people from the last workshop, so great to see you all again. So I'm going to go ahead and share my slides and give you a brief intro on what you're doing here. So this is an introduction to public health data science using specifically the R programming language. And this workshop is based on work that I do very regularly. You should have gotten a notice from me on how to set up R in RStudio based on whether you have a Windows or a Mac, and how to request an API key for the data that we will be retrieving for this workshop. But just in case you didn't get the materials, they are hosted on GitHub. So I'm going to go ahead and put it in the chat. I'm sorry. Let me go ahead and put that right there for you all. And then if you go on the right-hand side, there's a link to the slides, which are hosted online. And I actually prefer you follow along with those slides versus the PDF itself, just because there are links and very useful resources, which don't make it into the PDF when you export. So this repository will remain open for you all whenever you need it. And in this repository, there is a data folder that has instructions on how to obtain data from request an API from the US Census Bureau, which is what we will be using. It normally takes about 2 to 4 minutes. Several people have told me that they have not received their API key. I believe this is due to making a request outside of business hours. This is the Census Bureau. So I think services are delayed when you request things outside of business hours. But not to worry, I made a separate API key for this workshop that I will share with you. This is not good form. I will get to that later. It's only for the purposes of this workshop that I will share it for you. And then after this workshop, I will decommission the API key. API keys are never to be shared with people, and that is the agreement. Thankfully, I've read the terms and agreement for the census, and there isn't a clause about that, but I have one that we can kind of as for a testing development purposes. All right, so let's hop right into it. I think we have everyone that is going to be joining us. So I don't know if Farzana is on the call or not. If we can just go ahead and close the workshop.
We did.
Awesome.
Bella.
Awesome. Thank you very much. All right, so a little bit about me. I am a research analyst at the University of Miami, where my research primarily focuses on those with substance use disorder, specifically opioid use disorder. And a lot of the stuff that I'm going to be showing you in this workshop are things that I do on a very regular basis. A lot of people think as data science they go immediately to the complexity of machine learning and AI. Is probably the last 20% of any data scientist work. You have to get to that point first. And that is really the hard part, is getting your data prepared and getting to that 80%. So the stuff that I'm about to show you right now is stuff that I do very regularly, are functions I use very regularly. And the data that we're going to be used that comes from the census, you may be asking, well, this isn't health data. Well, it is, because you will be surprised how many times I get asked for any estimate what is our population look like. This is usually the denominator for a lot of our estimates. You can't do population science without understanding your population. So we have, I'm constantly pulling for any given geography, the total number of people living in, let's say in Miami-Dade County, broken out by sex, broken out by race, broken out by age group, all of these subgroups that you have to create to get specific estimates. That's typically your denominator in a lot of calculations. So I figured this is something that if you're going to get into public health data science, you're going to have to get familiar with using the census. So just by a show of hands, very, very quickly, use the raise hand feature on the chat. Raise your hand if you have familiarity with R&R Studio and already have it set up. This is actually really important to get a gauge on how many people are going to be using the cloud environment. So I have, just in case people were not able to get R&R Studio set up prior to this workshop, I went ahead and set up a cloud environment for this workshop but there's limited seating in there. But I want everyone to have a chance to be able to do the exercises in this workshop. So please raise your hand. It's really important so that I know make sure we have enough resources for everybody. So there are only 4 hands I see raised. Okay, 6. Okay, so we should have enough resources for everyone. So go ahead and put your hands down. And then also this, excuse me, this workshop is going to be very dynamic. I expect you all, if you have questions, you can unmute yourselves, stop me, ask a question. This is much more natural, in my opinion. When I teach, I tell my students this all the time, feel free to interrupt because it keeps the flow very organic. I don't want you missing out material, feeling like you have to memorize and remember your question until there's a pause for questions. So no worries whatsoever. And we may have some hiccups along the way. Something may not work for somebody, but I also want you to please use the chat feature and post your question in the chat for everybody to see. And that opens room for collaboration and people can help each other out. All right, so let me go ahead and switch. You guys should, I already put in the chat where to get the material, but it's here just in case as a QR code. It links you directly to the GitHub repository. In the GitHub repository, like I mentioned, has the main files that you will need, which is the slides, if you prefer the PDF versus the web form. And this R Markdown document. This is what you're going to need. For those of you that have R&R Studio set up in your environment, download this file. This is what we're going to be working off of. And then for those of you in RStudio Cloud, you should be able to go into the cloud environment and you'll see that there is a project already set up for you. Cloud environments have more limited resources. So I went ahead and installed all the necessary packages for you versus those of you that installed R&R Studio out of the box. A lot of the packages the only package really that we will need to are not included. So you will have to install them. That shouldn't be an issue. All right, so let me get into the big picture, which is what is data science? And data science is like a very buzzy word as of the past couple of years. It's really become a feature in the last, like a really hot topic within the last 5 to 10 years. But data science has always been there. It's not a new field at all. It kind of started in the 70s. We have a statistician that goes by the name of John Tukey. You may have heard of the Tukey test. He writes a book called Exploratory Data Analysis. And he says something, he has a quote in there that says something along the lines of that he thought he was a statistician until he started watching the fields of statistics and mathematics evolve. After which he began to have a lot of doubt. And from that doubt, he realized that his main interest was actually in the data analysis process, in which he felt was intrinsically an empirical science. And this is where he starts to realize that the analysis process is a science in of itself. And around the same time, the late 70s, we start to see relational database management systems start being used. In the 80s, we see data mining. People start to collect, and companies start to collect a lot of data that they actually have to start implementing data mining practices to answer their questions. And then in the 90s, we get the term big data. So corporations start to collect a lot of data in real time, and it comes in long and wide and, capacity wise, big forms. And so that term was actually coined in 97. And statistician, actually, like data scientist, was actually already a thing. But it was actually interchanged with a statistician. So that role was kind of used interchangeably up until about the 2000s, when analysis kind of, like data analysts kind of adopted, analytics were adopted to highlight the usage of predictive modeling. So by 2008, we already have what is what is known today as your data scientist. That includes your analysis, your exploratory process, your transformation, and then a little bit of predictive modeling and domain expertise. But it is a very broad field. People get into it from all backgrounds, and there is so many resources that there is no one way to become a data scientist. And to me, that's the beauty of data science. You're not limited based on what you chose to do in undergrad. You can pick up from anywhere. So many people have asked me this question, and I tell them the exact same answer. All you need is one part math or stats, a little bit of math stats background, one part programming and database knowledge, so SQL, and then one part of domain expertise, shake well, and you got a data scientist. It's really not that hard. And besides, even if the data scientist term, like quote unquote data scientist, evolves into another role, data is everywhere. Data, it's not going to go away. So this position will always be in demand. So let me tell you a little bit about how the untrained do data science. And I am 100% guilty of this. I've done this. Collect your data in an Excel spreadsheet, run some summary stats on it. Maybe you use one of the plugins from Microsoft. They like to include it at the top. Realize that, you got some weirdness going on in your data. So you fix your data itself in the same spreadsheet. Use that import menu again, or that plugin, whatever analysis tool that you use in Excel. Point and click and do more things and actual fixed manipulation in your code. Copy and paste those numbers into a PowerPoint or Microsoft Word document and then ship it out. This is very antithetical to what's called reproducible research. And any data scientist, any good data scientist will tell you the key, the foundation of being a good data scientist is you don't have to know the most complex machine learning algorithms, but you need to be able to do things in a reproducible manner. And that is very, very important. So many studies, a study came out that found so many studies were not able to be reproduced, which is a problem. If somebody cannot reproduce your results, what does that say? That leaves for so many questions about your methodology, your conclusions, and the validity of your entire research, which is a lot of money and time wasted. So why did I pick R versus Python? Python, there's always that, you're going to see that Python versus R debate, but I really appreciate R. because it is a programming language designed for statistical computing. It is developers design statistical software and packages specifically for analyses, for statistics. So, for example, there are packages for survival analysis, for bioinformatics, to calculate age-adjusted incidence rates, for power analysis and structural equation modeling. And it's free, it's open source, and somebody out there has developed a package for it. Hence why we use it a lot in academia and academic research, and then even in the healthcare space, because it's very strong. Python is also a very strong programming language. It's very general purpose, but R was specifically designed for statistical computing, which is why I prefer it in this kind of in this space. Also, this is going to be very nerdy, but it's because I also love the giant community of programming and stats nerds out there. There's a whole community called UseR, so user with a capital R, and they're very, 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 I've never met a community so friendly to help you, no matter how dumb you think your question is. You can post it on Stack Overflow or any public forum or even Twitter and use the hashtag #RStats, and someone will have an answer for you, I promise you, within like 5 minutes. But there are two main philosophies, like ways of thinking within R. There is base R, and that's what comes out of the box when you download R. And then there is something called the Tidyverse. So these are what I have on the screen are some base R functions. You have C, which is the concatenate function. I don't need to worry too much on what these functions actually do, because I'm going to teach specifically in the Tidyverse, but I'm going to show you how these exact functions, how they're done in the Tidyverse. So I don't want you to focus too much on these functions. There's C, that's the concatenate function. So whenever you see something ending in a parenthesis, that's a function. Then you have the square brackets, that's usually for subsetting, and DF is just shorthand for data frame. So you can kind of read that as pseudocode, which is pseudocode is an English way of writing code, or human readable way of writing code. The assignment operator, and that is your less than sign with a dash, looks like an arrow. Order, which is it sorts your data based on a variable, and then which is basically also like subsetting, but it returns, it is based on, it returns the indices in which a condition returns true. So don't focus too much on the exact functionality of what these specific base R functions. But I just want to show you, I'm going to highlight the differences. So base R versus the Tidyverse. So what is the Tidyverse? This is a quote that was taken from R for Data Science, which I highly recommend if you're just getting started in the R programming language. It is written by Hadley Wickham, the chief data scientist at RStudio, and it is very comprehensive. You can essentially do most of your data science pipeline with just that one book alone. So I appreciate it very much, and it's available online for free. Another one of the beauties of open source and the community. So he writes, at a high level, the Tidyverse is a language for solving data science challenges with R code. Its primary goal is to facilitate a conversation between a human and a computer about data. Less abstractly, the Tidyverse is a collection of R packages that share a high-level design philosophy and a low-level grammar and data structure, so that learning one package makes it easier to learn the next. I want to highlight the last part of that quote. There is a high-level design philosophy of the Tidyverse that allows it to be as such. If you learn one package within the entire, so the Tidyverse is an ecosystem of R packages. If you learn how to use one package very well, it's very simple to learn all of the packages within the Tidyverse ecosystem, because it is based on 4 main fundamental design principles. And I'm going to talk about the basis of which the Tidyverse was developed, and then those 4 main design principles. So as you can see, I have my Chrome browser open and I have tabs open so that I can show you what those things are. So we have the Tidyverse, the 4 main design principles, which is, it is human-centered, meaning that it is designed specifically to support the activities of a human data analyst. So the things that you actually need to do, none of these extraneous functions that you only serve like just one little purpose. You know, it covers everything. Like most of the things a data analyst needs to do, there's a function for it in the Tidyverse. It is consistent. So the packages, the arguments that those packages take in are usually consistent, meaning that, for example, most functions within the Tidyverse, their first argument is a data object, then followed by the function-specific arguments. So he writes here, so that when you learn about one function or package, it can be applied to another. And the number of special cases that you need to remember is as small as possible. So that's that ease of learning of the packages. It's composable. So one of the things I'm going to show you in just a second is a function technically, but it's called the pipe operator. It basically, it's what makes the Tidyverse so elegant. It allows you to take in a function and the process, take the output of that function, pipe it into another function, utilize that function, and the output of that function can be piped into another function. So it's very composable. You can literally stack multiple functions on top of each other, and the output of each will flow into the subsequent function to get your final output that you need. That reduces the lines of code and the amount of objects in your global environment, which take up memory space, and makes it a lot more human readable. And it's inclusive. So because the Tidyverse is it's not just a collection of packages, but it's also the community of people that use them. So there are a lot of packages that are officially part of the Tidyverse, but there are a lot of package developers out there that follow these Tidyverse principles. And this is actually the Tidyverse design. The Tidyverse actually has its own style guide that if your package follows those, could essentially be a tidy package. I helped develop a package for people who use data from RedCap. RedCap is a survey like database software that's used a lot in the healthcare space. And the output is a little bit messy. So my colleagues and I developed a package called Tidy RedCap. So it's has that tidy in the name because it follows these principles, and the output of it is also tidy, which is an important concept. There's also one thing I want to mention is that you may hear that the Tidyverse is okay, let's see, I already have a question. What should I put under organization name when requesting my API key? You can put whatever. You can put where you work. You can put your own name, since this is just for personal use. I don't think it really matters. No worries. Okay, so one thing I want to mention that you may hear about the Tidyverse is that it's an opinionated way of programming. And when a programming language is referred to as opinionated, it essentially means that this product believes its process is inherently better than the style in which it was originally developed from. So base R in this instance. So I know people that will strictly only use base R. They will not use the Tidyverse. I don't really understand why, but that there are people that don't do opinionated language programming. So if you ever hear that term being used in reference programming languages, that's what it means. So here are some of the advantages, if it wasn't already clear, is it is designed for functional programming. And functional programming, essentially, it means that your method of programming is functions. It is just based on functions. There isn't, instead of emphasizing, it is meant to emphasize the results, like what is actually to be computed and not the process in which it was computed. So R provides many tools for the creation and manipulation of functions. So basically the Tidyverse lends itself to a style of problem solving centered on functions versus object-oriented programming, which I'm not going to get into right now because we'll get lost in the weeds, but just know that everything is, your scripts are just going to be full of functions, and that's called functional programming. The functions in the Tidyverse are consistent, as we've gone over. You can create a workflow using that pipe operator. It's very parsimonious approach to develop of data science pipelines. So that, composability, and gets that because of all of those principles combined, you have a possibility of greater productivity. So I found this really awesome visual with the main packages in the Tidyverse to highlight the main steps of the data science pipeline. So you need to import your data, and there are some main packages. You have readr, that's the main one that you're going to use most likely. That's for reading in CSV files, reading in other R data sets. But you have readxl, that's for XLSX, XLS, Haven, that's for data sources from other statistical software packages such as Stata, SPSS, SAS. HTTR, RFS, and XML2 are for web scraping from the internet. Then you're going to tidy your data. There's the Tibble and tidyr packages, transform, dplyr. We're going to focus heavily on dplyr today. You can do a lot with dplyr and also ggplot as well. And then, which is for visualization, and then modeling, which we will not cover in this workshop. And then the general programming packages that are very useful is Magritte and Per. And Magritte, actually, if you guys aren't aware of the artist Magritte, he has a famous painting of a pipe, and underneath it says, "Ceci n'est pas un pipe" in French, which means this is not a pipe. So it's that was kind of the, I wish I had a picture of it, but that was the influence of the Magritte package. I love this tweet by Dr. Andrew Heiss from Georgia State University. He is a data science instructor, and he is saying that, and this tweet was very recent, he was saying that he teaches the Tidyverse to students for years, and they actually get the concept of the pipe very quickly and understand its benefits and utility. And this is what the pipe looks like, by the way. It's the % greater than % sign. So typically you would have, without it, you would have to nest a lot of functions. And nesting is basically when you insert one function into another function. So basically, if you look at the first part, you see leave house. But in order to leave the house, you need to get dressed. But in order to get dressed, you need to get out of bed. But in order to get out of bed, you actually have to wake up. And that's all centered around me. But I have to wake up at 8, and I have to make sure I get up at the right side of the bed and make sure that I'm wearing both the pants and shirt, and that I get in my car and not my bike. But with the pipe, it's really simple and it's more elegant to read. You have me, and I will pipe that into wake up at 8, get out of bed on the right side, get dressed with the pants and a shirt, leave the house with my car. Easy breezy way of reading code. So the Tidyverse, I've included a link here. So whenever you see this this is actually an active link. This is the Tidyverse design guide. Has a package called dplyr for data transformation, and there are 5 main dplyr verbs. And you might hear this if you decide to read up on R for data science: filter, arrange, select, mutate, and summarize. Now, this is where I want to demonstrate those main functions, but let's go ahead and make sure for those of you that are using, because there's still a couple things that I want to say before we start coding, but in the meantime, I will speak while you guys go ahead and switch over to RStudio Cloud for those of you that are in the cloud environment. I will put it in the chat. Excuse me. For those of you that need the cloud environment, I've included the link to the chat. I intentionally didn't put it in the GitHub repo just because I wanted to preserve the space for today. And then for those of you that have R and RStudio on your laptops, go ahead and have the R Markdown file loaded. So the way you do that is go into RStudio and you hit File, Open File, and navigate to where the RMD file is, and just hit Open. And if you are using, if this is a fresh install for you for R and RStudio, I can't remember if the tutorials that I included in the GitHub repo included Tidyverse, but if it didn't, I want you to go ahead and go into the console. And my setup of RStudio it will look a little bit different than yours. I have my panes organized, structured a little bit differently, but the console I think is on originally comes in the bottom right corner, bottom left corner. I want you to install packages, Tidyverse, dependencies equals true. Okay, I'm not going to hit enter because I already have it. And it's already also here, but it's just commented out. If you have the R Markdown document loaded, you can just erase the £. So the £, is how you comment out a line of code. And then you can run the chunk by pressing the play button on the upper right-hand corner. So please go ahead and do that while people are getting into the RStudio, the R Cloud environment. And while I will continue to speak just a little bit more on what we're going to be covering in just a moment. All right. So as you guys are setting up, and feel free to, I have the chat open. So if you run into any issues, I'll monitor that as well. So as I was mentioning, the Tidyverse, it was designed on a particular philosophy, and that was the Unix philosophy. You can read up more about it in the resources section at the end of the slides. There's a whole list, there's a whole history of the philosophy, but basically Ken Thompson, I can't remember his name, Thompson, I think is his name, who developed the Unix operating system, came up with the main philosophy about how computer scientists should develop operating systems and software in the future. Then you have a few other men in the process, in the 80s, assigned to add upon his philosophy or manipulate it. And then he comes back and he says, okay, well, times have changed, and, let me just come up with a more Zen approach to software design by listing out, taking my original philosophy and all these additions to it and setting some and breaking it out into a set of rules. And one of them is the book. Okay. For data science. is rule number 4, and that is fancy algorithms are buggier than simple ones, and they're much harder to implement. Use simple algorithms as well as simple data structures. Basically, write simple parts. Being clear is better than being clever. Design programs to be connected to other programs. So the concept of modularity. Write a function that does one thing really well, write multiple functions and that only do one thing and do them really well, and call them so that you don't have to keep writing lines of like the same lines of code. And then when you must fail, make sure you fail noisily so that you know something is wrong, because I cannot stress enough how annoying it is when you write a script and you think it worked amazingly and there is a bug in your output, your numbers don't look right, and your stakeholders call you out on it. It's really embarrassing, but you had a bug in your code, but you didn't even know it because technically it was running smoothly, but there wasn't a check in place to make sure that it was operating as intended. Maybe I used I put mean instead of median or something like this, something silly that doesn't cause the code to break, but doesn't produce the output I want. So this is kind of what the Tidyverse was based upon. And there are some specific rules that I want you guys to take into account when you're working with the Tidyverse. And those are how your names and your variables should be formatted, meaning that your file name should be meaningful and do not contain any special characters, no spaces, no exclamation points, no whatever, any other characters besides, just like short letters and numbers. It'll make your life a whole lot simpler. If files should run in a particular order, like if you're iterating through files, prefix them with numbers. That will make your life a whole lot easier. So in your directory, this file needs to run first, prefix it with 1, then the next one, 2, 3, 4. So it makes, it's simpler to write program that way. Use commented lines of a pound followed by dashes or equal signs to break your file into easily readable chunks. The RStudio IDE is smart enough to pick up on those, that pattern, so you can quickly jump to different chunks of your code without having to minimize the number, unnecessary scrolling. Variable function names should only use lowercase letters and numbers and not and underscores. So typically our programmers, you'll see, use what's called snake case. And then generally your variables should be nouns and your functions should be verbs. So for example, my line 1 in this code chunk is a separator. It's a pound sign, the name of my code chunk, followed by a sequence of dashes. Then you have, this is my var. So my underscore var is appropriate variable name. You have var underscore 1. That's also appropriate. You can have a letter, numbers in your variable names, but they cannot begin. Your variable names cannot begin with any other non-alphabetic character. So you can have numbers, but they cannot begin with a number. And then this is a function. So you have make names. So you have that verb in the beginning. So the typical data science pipeline, if it's not been made clear already, I have a pretty visual that I took directly from R for Data Science, is you import your data. You're most likely going to have to do some tidying of that data because it may be messy and contain information you don't need. Then you have a transform, visualize, and model loop, because it's an iterative process. Cyclical process, as many of you will come to find, is you're going to do some transformation and you're going to visualize, and you may notice some patterns that you didn't expect. And then you're going to model, and that output of that model may require you to maybe create new variables based on, 2 other variables. And then so you'll visualize it some more. And then until you come up with something that you like, it's hardly ever the case where you will transform and visualize and model in the first time, and then communicate your output to your stakeholders. It's a learning process. So that's why that is in a cycle. And the last step being communicating your results. All right. So, and then the final thing I want to talk about before we get into the code is ggplot2, and that is based on the grammar of graphics. And you can read more on the grammar of graphics, but essentially it is it's like spoken language grammar, but specifically designed for building graphics. It's as simple as that. ggplot2 uses something called layered grammar of graphics, which means that you can layer multiple features. So you can have a scatter plot, and then with the plus operator, you can layer a regression line on top of it. So that's what's called layered grammar of graphics, and that's what ggplot2 is one of the biggest advantages of ggplot2. And actually, expert data visualization folks will use ggplot2 a lot, and then export their plot into something like Adobe Illustrator to make beautiful data visualizations. All right, so I'll get to these when we get into the code. So let me see a show of hands. How many of you have any difficulty, or go ahead and use the raise hand functions if you still don't have RStudio or can't get into the cloud, because we're going to jump right into this code right now. Okay, so I think everyone is set. So you have this R Markdown document set up in front of you, and you might be wondering, what is RMD versus .R? So R Markdown for me is a really great way to present analysis and results in a reproducible way. So I often use R Markdown documents when I'm actually, when I'm teaching or giving a seminar like I am right now, or when I need to present my results to some key stakeholders at work that are not part of my team. Because it allows me to include my thoughts in an R flavored version of Markdown. So Markdown is a markup language. So you can, I can write my thoughts, mark them up with bold or italicize, underline, 3 pound signs, a level 3 header. You can learn about that in your cheat sheets, which, by the way, that reminds me, for those of you that are in the RStudio Cloud and RStudio Cloud environment, one of the beauties about helpful things about RStudio Cloud is that they provide all the cheat sheets for you. So if you go on the left-hand side, RStudio provides a bunch of cheat sheets that are amazing. Why, like for me, why memorize anything when there's a cheat sheet? It just makes your life a whole lot easier, right? And for me, the ggplot2 cheat sheet is probably one of the ones I use the most, because it's very straightforward and it tells you if you need to make this kind of plot, these are the geoms you need to use. So we're going to get into these are good things to download on your computer and have them handy when you're picking up R for the first time. All right, so let me go ahead and jump right into this. So as I was saying, R Markdown is a very good format to use your code, to structure your code, because I can write my thoughts in text and then have code chunks in it as well. And then I can export it into Word or an HTML document and send it to whomever I need. And it will have my analysis thoughts with my plots. I typically turn off my code, so because my stakeholders don't need to see my code, but it'll have the appropriate output. And it's a very nice tool. All right, so you remember those 5 dplyr verbs that I was mentioning before? We have filter, we have arrange, we have select, we have mutate, and we have summarize. So I'm going to demonstrate how to use them right now. So filter It does exactly what it sounds like. It filters your data down to only the observations you want to keep. And that is a something that is good to bear in mind. Not the variables you want to exclude, the variables you want, not variables, the observations you want to exclude, the observations that you want to keep. So after you've loaded the Tidyverse, so to load a library, you simply write library quotes the package that you want to load. And so we're going to load the Tidyverse. And to run a specific line of code, instead of running the entire code chunk, this play button will run the entire chunk of code. The command to do that is command enter or control enter, depending on whether you have a Mac or a Windows machine. So you can hit command enter to load the Tidyverse, and you'll see that little green bar show up, and your console will also show you the last line of code that was run. And then the miles per gallon MPG data set is preloaded in the Tidyverse. So the Tidyverse includes some test data sets that you can play with. So that's what we're going to use. And to load them, you simply run data MPG. There you go. So we have the MPG, the miles per gallon data set here. And if you click on that blue button, you can see the variable names and their classes. So we can see that model is character, and displacement, I believe, is what DSPL is a numeric. And whenever you don't know for one of these preloaded data sets what it is, or for any data object that comes in a package or function and you don't know or remember how to use it, you can merely just put question mark MPG, in this case, because this is a data set, in the console, and it brings up the documentation. Any package that you install must come with documentation for your either for both your functions and any data that comes in it. So they must be documented. And this is the key, like I mentioned, to reproducible research is proper documentation. Okay, so let's say, for example, I want to filter down the miles per gallon data set to just the cars that get greater than or equal to 30 miles per gallon on the highway. So what I would do is I would use the filter function, and I've commented the syntax is typically your first argument is the data object and the second is your condition. So I will run filter miles per gallon highway greater than equal than 30. And I can do 30. I can write this as a number because if I look at highway, I'll see that it is an integer. I don't have to write it in quotes or can do any conversions. It is an integer, so I can write it this way. And you can see that it prints it directly in my script. If this was a .r file, .r is primarily what I use. It's literally just R scripts. It's not an R markdown, which means allows me to have all of this text around it, because this is not, if the R will not be able to interpret this if this was in an R script, a .r script. If I were to just run this, it will actually print it in the console. So this is a data set that I want to use in further steps. So we need to assign this to something. So remember, the assignment operator is that arrow that looks like it's pointing to the left. That allows us to assign the miles per gallon over greater than or equal to 30 to a new data set, which I called good MPG. And let me just tell you that the shortcut, the keyboard shortcut for the assignment operator is, if you're on a Mac, Option dash, or if you're on a Windows, it's Alt dash. You just do that and it pops up. These little shortcuts really help make your life go much smoother. So let me just hit Command Enter. That's to run this line of code. And now you see we have in our global environment, and our global environment are objects that are available to us globally. So in any script that I'm writing, I could, create a new script and I could still access, filter, good, and it recognizes it because it's in my global environment, even though I'm not in my R Markdown, I'm actually in a new file, but it's because it's already loaded. So it's available globally. That's what that means. All right, so I want you to spend, about 30 seconds, and I want you to try the filter function on your own. So replace this here, this little chunk that I put here, and my data, call it whatever you'd like, because this is what you're going to be using. And I want you to filter the miles per gallon based on any variable that you see. So explore it. You can click on the MPG data set, and you can see the variables that are available to you. And you can use any logical operator to filter on. So you have less than or equal to, you have greater than or equal to. And remember, if you want to use equal, you have to use the double equal. This is a single equal sign is a mathematical equal, and the double equal sign is logical equal. Let me know if that doesn't make sense to you, but this is what you will do, okay? And I don't know what happened to the chat. I don't know if anyone is. All right, let's see. Let's see. There's an error. How to show output in Word? I know there are some packages. Which one would you recommend? So within our Markdown, Zoila, I'm sorry if I completely mispronounced your name. There is this, hold on, I need to hide the meeting controls so I can show you. There's a package called Knitter. It is called Knitter. And it allows me to take this code and knit it directly to a Word document. So I can take this and that would be that. And it depends on the settings. And this is, I'm not going to get too much into R Markdown. This is where I want you to utilize the R Markdown cheat sheet because it has all of that information. And so you can choose to say, I don't want this particular code chunk to show up. So show nothing. Don't run the code. Don't show the code at all in when I export the function, when I export the document. All right, let's see. There's no package. Yeah, so you need to make sure to install the Tidyverse. So in line 14 of this document, there's a line that says install packages Tidyverse dependencies equals true. I asked you guys to do this a while ago because it's a bit of an install. Just uncomment. So I had this line commented, just delete the pound sign and run that line. All right, so let's keep it moving. So we have the second function, it's called select. Select lets you keep the variables that you'd like. So we see our miles per gallon data set has 11 variables, but we don't need all 11 variables. So where filter lets you filter only the rows, the observations that you want to keep, select lets you keep only lets you keep the variables that you want, which actually is a really good thing. And take a minute to read this note that I have on line 55. This, we're going to use the pipe operator for this because there's no need to keep repeating the same lines over and over again. So we're going to take our good miles per gallon and we're going to pipe it into the select function. And the output of this filter MPG highway greater than or equal to 30, with the pipe operator, that output gets put into the first argument of select. Because if you'll notice, there is not, MPG is not explicitly stated in select, although select, like all tidyverse or dplyr, specifically dplyr functions, the first argument is always the data object. But with the pipe operator, you don't always have to specify, because the output that came subsequently is going to get piped into the following, sorry, not subsequent, prior is going to get piped into the subsequent function. So this line, we have our filter data set on highway greater than or equal to 30, and we only are going to select highway, a displacement, year, cylinder, city, and class. That's it. So far, so good. All right. The third variable we're going to use is the mutate function. Variable function. Mutate allows you to create new variables in your data frame. So I want to know what is the combined mileage of these cars. So a simple Google search told me that there's a simple formula to do combined mileage, and that's you take 55% of your city mileage and 45% of your highway mileage, and that gives you a combined mileage. So I'm doing the exact same piping as I've done. So we've used filter, we've used select, and now we're going to pipe that output into a mutate. So we've filtered our rows, we've selected only 6 variables, and now we're going to create a 7th variable called combined MPG. And to do that, we're going to, and this is where the single equal sign comes in, not equal, is equal to 0.55 times city plus 0.45 times highway. So you use the mathematical operators, you have the plus sign and the asterisk for multiplication. And then I've wrapped that into the round function. And somebody from the last session asked me if base R functions can be used within Tidyverse functions. And this is one of those cases, because round is actually a base R function. So I don't get a 10 digits after my number. I rounded it to the nearest whole number. So if we run good MPG, if we run this code chunk, we now can see that we have a new variable called combined MPG rounded to the nearest whole number. So far, so good. All right, so now we're getting to a range. A range is quite simple. A range simply does what it says it's going to do. It's going to sort, it's going to arrange your data based on a variable. And so we have our filter, select, and mutate statements, but arrange by default arranges your data in ascending order. But what I want to do is I want to arrange my data based on my new variable combined MPG, but in descending order. So we're going to use that in conjunction with the DESC, desk, that's for descending, desk function. So if I run this, then, and go back to good MPG, you'll see now that the highest average combined MPG cars are at the top, and then it is arranged in descending order. Then finally, we have the summarize function. And the summarize function is, I want you to keep this in the back of your note as a little asterisk, that it is very useful. It allows you to do summary statistics on your data. However, it will only return your summary statistic. Like, it'll only return your new variable that is your summary statistic. It will not be a new variable unless you can use mutate for that, but summarize will only return your new summarized variable. So look at lines 94 through 105. We want to, I'm going to save this as a separate object because I will need my good MPG data set. I may need to use average MPG. So we have all the same steps: filter, select, mutate, arrange. Then finally, we have a summarize function where we create a new variable. It's called average combined, where I take the mean of all the combined MPGs in my data set. Now, at this point, you're probably thinking like, this is really redundant. Why do we keep using the same like 5 lines of code when we already have stored it? When we used arrange, we stored it. Good MPG now includes filter, select, mutate, and arrange. We don't need to repeat those steps. You're absolutely right if you're thinking that. The best way to do what I need to do is basically just call on my new data object, good MPG, and pipe that into my summarize instead of repeating all of these lines, because that just contradicts why we have pipe operators in the first place, right? So when I run average MPG, I want you to see that we only have one observation and one variable. And that's my combined, my average combined mileage, and that's 28.7 miles per gallon for all of my 26 cars that I decided to keep. So let's do a little bit of plotting. We're gonna skip the questions. I included some questions that I want you to keep in mind. And this is also primarily for, if you come into the future and you use this code as a reference, just some like bits, some food for thought as you run these chunks of code. But let's go ahead and move on to the plotting part, and that's the most fun. And if you read Hadley's R for Data Science, you're going to see that he basically uses, that's the first thing he will do, is he will teach you ggplot2 first and how to plot, because he believes in the concept of let them eat cake first. It's kind of funny, but it's the most fun, and then it'll get you more engaged. So now that we've used the 5 main dplyr verbs that are used in data transformation, we're going to get to the fun part. So I've added a few notes up here about ggplot2. It's designed to work with data frames, not individual vectors from a data frame. So you can't go in and you can't do, you can't pass in good MPG, good MPG $ combined MPG. So, and just as a side note, you can reference an individual vector in a data frame. And by vector, I mean a variable, by simply calling it with a $. And that is actually notation from base R. So I can do good MPG $, and it autofills, you can see, the RStudio IDE, and I can select my new variable and it'll spit out the value. So that's what's called a vector. You cannot use this in ggplot2. It has to be the full data frame. All right, so this is the typical, I've added a little pseudocode here. This will not run, but typically you say ggplot, you call the ggplot function and you supply it your data frame, and then a geom function. So in my head, there are these things, well, there are what's called geoms. So you can have things called, like for example, geom bar for bar plots, geom point for scatter plots. In my head, I think of them like geometry. So what is it you're actually trying to plot? You can't have, if you just run this, you will have a blank slate. You need the geom function. So this is where the layering comes in. And actually, ggplot, unlike the rest of the Tidyverse, within the ggplot does not work with the pipe. It works with plus. This is what I mentioned earlier about layered grammar of graphics. So this is the grammar this is the grammar of ggplot. You have your data, and then you have mappings. You have your data mapping, you have your aesthetic mapping. So this is your data mapping up here. And then you have your geometry. So I'll show you in just a second. You have your aesthetic mapping, which is your X variable and your Y variable, for example, if you're doing a scatter plot. So let's try it out. Let's make a bar plot. So you can pipe your data object because ggplot is a tidyverse function. ggplot is a tidyverse package. The first argument of ggplot is a data object, so you can pipe into it. But everything after you do that is actually going to be using the plus sign because it's a layered grammar of graphics. And I've included a resource for grammar of graphics in the resources section, and I highly encourage you to read up on that so you get a little bit understanding of how ggplot works behind the scenes. So we have good miles per good MPG, our data set that we've created, and we're piping that into the ggplot function. And we're using AES, that's our mapping, where we supply X equals class. So class is a variable of good MPG. So we have subcompact, compact, mid-size. So, and we're going to do geom bar. So if I run that line, we can see the distribution of compact versus subcompact versus mid-size cars. So we can see we have more compact cars than subcompact and mid-size cars, which makes sense for the higher mileage that we're looking at. But let's look at geom call. Okay, so they're very easy to confuse because they both produce what look like bar plots, but geom call actually requires a y variable. So you have your X variable, which is class, and then you have combined MPG. So this lets you look at the relationship between the two variables as a bar plot, but you have to be really cautious here. So I included this line of code as a precaution because I want you still see the same trend, so more compact cars, but look at combined miles per gallon. Look at the y-axis. We don't have any cars that get over 300 miles per gallon. This is a sum. So you need to be very cautious on how you use your geoms. This is the main takeaway I want you to take, is that be cautious of what geoms you use and how best to use them. All right, so, and as I mentioned before, there is a good way to figure that out is using a question mark on any data object or function in the console will give you an explanation, will give you the documentation, which includes the explanation on how those functions ought to be used with examples. So if I do geom call, you can see that it is a type of bar, but they have a slight difference in the height, the proportion. So you can read the documentation on that just by putting a question mark in front of the function and putting it in the console. So actually, I think it would be more useful to make a scatter plot. So I'm going to make a prettier scatter plot, in my opinion, and do the good miles per gallon data frame, pipe that. Oh, and if I haven't already mentioned, the pipe operator, the keyboard shortcut for that is Command-Shift-M or Control-Shift-M if you're on a Windows. So to recap, Command-Enter or Control-Enter to run one line of code, Option or Alt-Dash for the assignment operator, or Command or Control-Shift-M for the pipe operator. Those are like the three main keyboard shortcuts that you will need to know, and it'll make your life so much easier. All right, so we have ggplot data equals good MPG. This we did not need to supply, but for illustration purposes, because we've already are piping that in, and that goes automatically into the first argument. So I could just delete that. That was redundant. Mapping equals AES. So AES is aesthetic, where aesthetic is you need to supply your X and Y. And you could also, there are other arguments in the AES function that you could supply, but for our purposes right now, we only need our X and Y variable. So we're going to look at the relationship between year and combined miles per gallon. And because I don't like this boring default look, I'm going to make my dots, my geome point. So remember, you have to include a geome. So for scatter plots, it's geome point. And I'm going to make it hot pink. And here you can literally use whatever color you want. Look at the hex code. Just Google like hex code generator. And there are a lot of like free resources, and you can plop them right here in as a character string. And then I want to use a theme, a minimal theme. So there are a lot of themes that are included in ggplot2. You just look at the documentation for ggplot2 and those cheat sheets I was mentioning earlier. And then I also, for presentation purposes, I don't want to keep the labels, my X and Y labels, my variable names. Those aren't pretty. So I'm going to format my labels to make them more clear. And then this is what I get. So what does this plot tell me? Like, we have most of our cars either come from 1999 or 2008. Like what happened between 2000 and 2006 or 2007? I have no idea. I guess people got into more fuel guzzling cars. I'm not sure. But all right, so it might be more useful to see a continuous variable broken down by a categorical variable. And this is where a density plot may come in handy. So let's quickly go over this, because I really want us to get into our actual data, like our actual hypothesis and the data that we're going to be working with. So all of this is basically going to be used when we use our actual data from the census. Yeah, Maria says crazy years with gas guzzling cars. Yeah, I agree with you. So we have our good miles per gallon, and we're going to pipe that into our ggplot function. Again, this is, that was redundant, the data equal the good and MPG. We have our aesthetic, our X is going to be this time our combined miles per gallon, not our Y. And our Y is actually going to be a density. So there are select, if you read the documentation for ggplot, there are select functions that, not functions, there are select metrics, I guess, that you can pass that it will recognize. And one of them is a density. And the way to do this is a dot dot density dot dot. I'm not going to get too much into the weeds of this, but it is used, if you read that R for Data Science book, Hadley Wickham goes into this kind of notation and what other things that you can put into Y that are not actually a variable of yours, but if you wanted to include like a mean or a median, for example. So I'm going to use geome and something called a freq poly. Okay, this is a frequency plot. Something different though, I'm in my aesthetics, I'm not including a specific color. I'm passing in a variable. So instead of, I want to see this is how I'm going to group my plot. So you can pass in a variable into a color object, into a color aesthetic to group differences, to see different colors based on that variable. If that makes sense. So we have three main classes of cars. So we're going to have three different lines with three different colors. So if I run this, we're going to see that we have crazy fluctuations. It looks like our combined mileage and the density in our data based on compact, midsize, and subcompact. But I want you to notice that RStudio is giving us a little warning, like your bins default to 30. So if you know of a histogram and you understand like there are bin widths, so actually to make this frequency plot, R is binning your data based on your based on the variable, which in our case is combined MPG. It defaults to 30. It's telling you pick a better value for bin width. That makes sense because our variability in combined miles per gallon doesn't go like between, it's only like 1 or 2 or 3 miles per gallon, not 30. So this doesn't tell us much. So we have, if I change the bin width to 2, we have a little bit more understanding of our 3 classes of cars. So you can see that the mid-size cars have a higher density, like high representation in our data set in relation to their combined mileage. So, all right, let's go ahead and get into our data. Finally, the good part. So for those of you that, and let me go ahead and switch back to the slides really quick. I want us to get into our data. Our hypothesis, we have generated a hypothesis, and that is that places within Miami-Dade County with higher income have lower percentages of food stamp recipients. The data that's going to supply that we're going to be working with is the Supplemental Nutrition Assistance Program, otherwise known as SNAP, benefits for 2019. It's a 5-year estimate. So from 2015 to 2019, average of SNAP recipients in Miami-Dade County. And that is, the source is the American Community Survey, which you guys should have received an API key. And if you have not, I have a test one that you're going to use that it will be decommissioned. And it's from table S2201. And the geography is going to be our census tracts in Miami-Dade County. And the main package we're going to be using is the Tidy Census package. And the Tidy Census package is an awesome R package that allows us to interface with the US Census Bureau's decennial and 5-year surveys and returns it in a Tidyverse ready data frame. If you've ever used data from the Census Bureau and you've used the export function, like export to CSV, the column names, like it will give you a spreadsheet with the actual data and another spreadsheet with the metadata. And it's just a nightmare because the variable names are very, very not human readable, may make no sense. So this is a very, very helpful package in R that utilizes the Census API, and that stands for Application Program Interface. So for those of you that have not heard of an API before or never used one, in brief, this is how an API works. It basically allows your code, just like your RStudio, like your GUI, allows you to interact with your code. An API lets your code interact with other code. So your RStudio and the Tidy Census package is going to do what's called an API call to the servers at the US Census Bureau. And it's going to make a request and it's going to pass your API key to the server. And it's going to say, and the server is going to, it's basically going to ask like, hey, I need this data specifically. Here is a API key. And that server is going to check whether or not that API key is identifiable and therefore authenticate you. And then if you are authenticated, it will return the data that you requested back to you. With the census, it's a little bit more lax, but there are several APIs that you can use. Like I used APIs from Twitter, for example. Any social media platform, they're very stringent. You do not share API keys. That is a big no-no. People can do bad things because they're linked directly to you and you can have a lawsuit on your hands. So again, do not share API keys. All right, so I'm going to skip past this part because we'll go through it in the code. but we're essentially going to do exploratory data analysis. And some key terms that I want you to know is of what a variable is. So it is your quantity or property that you can measure. What is a value? What is an observation? So it's observation is basically like a row in your data frame. What is variation, which describes the behavior within your variable. And then covariation is how variables interact with each other. So one of the main things that we're going to do is create a histogram, and that is divides your x-axis into equally spaced bins and then uses the height of the bar to display the number of observations that fall in each bin. So we kind of seen that a little bit with geom bar, but instead it's going to be proportional. So there is geom histogram. So there is a geom just for histograms. So it's a really great starting point to examine the distribution of a continuous variable. This is some additional information on box plots and correlation, but let's go ahead and jump back into our code so we can start playing with our data. All right, and so several of you also had issues getting an API key. What I'm sensing is that because if you are just requesting a key right now and it being Saturday, they are slow to process on not business hours. This is the census, so government that we're working with. So if you had requested, when I've requested data from, an API key during business hours, it usually takes like 2 minutes and you'll get an email with your API key. So what I want you to do is go ahead and install packages Tidycensus. For those of you on the cloud environment, it should already be installed, but just double check by running library Tidycensus. And for those of you on your own machines, uncomment this line and run install packages Tidycensus. And it should, it's not a very big install, so it shouldn't take a very long time. All right, and then for those of you that have your API key, I want you to uncomment line 186. And you actually have to store, there's a place in R that is for this kind of sensitive private information. So the Tidycensus includes a function, they've written a function called census API key that will store your API key into a hidden file called .r environ. And this is where your environment variables get stored, and it's hidden from your projects and it's hidden on your computer. So it's for sensitive information like this. So I'm going to go ahead and share with you a key that you can use. So for the few of you that were not able to get it set up, note, you're going to have to request at some point rerun this line when you finally do get your API key, because after this workshop, this key will be decommissioned. Okay. So run this line so that your key gets stored within R, your R environ file. And then we're going to get our snap data. So we have a function in, and Maria, I hope that answered your question, because I see you still have your hand raised. All right, so we have a function called getACS from the Tidycensus, and it allows us to get data on the track level. And I make comments. So this is reproducible. So I want you to also take note of how many comments I've left within this document, so that if we run out of time, which we probably will, we have 5 minutes, you are able to continue and run this on your own, and should be without any issues because I've made comments throughout this document. But if you do, it should be fine. So Ina, it says if you cannot find function census API key, make sure you run line 183 and actually load the library Tidycensus. Are you getting an error when you run library Tidycensus? Okay, let's see. And you uncommented line 186. Okay, that installs it, but you need to actually load it. So that package Tidy Census successfully unpacked means that it was installed properly. So now you actually need to load the library Tidy Census. All right, so get ACS is a function from Tidy Census that allows us to specify which geography we want to get our data from, which table, what in what year, for what state, and for what county. Specifically, because we're looking at tracts, we do need to provide the county and the state information. Otherwise, it will just probably spit up, either give us an error or spit up every single tract in the United States, which is what we don't want. So if we run this line, it takes about 30 seconds. And you'll see, you know, when R is running something, when there's a little stop sign up in the console. Okay, it's done. All right, so we now have 118,332 observations with 5 variables. So there is a function called stir. And I have a question here. What do you think stir does? But I'm just going to tell you the answer. So stir gives you the structure of your data object. So it basically tells us it's a tibble of 118,000 records with 5 variables. It has all the variables are character except for estimate and MOE, which stands for margin of error. So the census gives us our estimate with a margin of error. And then I have a question posed that helps along with the exploratory data analysis, that we want to know what is our N, how many unique tracks are there? Because if you actually look at SNAP, you see that there are something called a GeoID, and then there are multiple tracks and different variables associated. So I'm like, so without even looking, like, which one of these variables is the variable we actually need? So there's a function in base R that tells us unique, which tells us if you pass in, like I mentioned earlier, you can snap $. This is how you reference a vector of a data frame. So if you do unique snap GeoID, pipe that into length. So you can use pipe with base R functions because length is also a base R function. We have actually 519 unique tracts in Miami-Dade County. So all of these are actual other variables. And just for kicks and giggles, we can go to data.census.gov and actually type in the table that we are working with. Oops, here it is. S2201 to see what we are playing with. Food stamp supplemental nutrition program. So it gives us a lot of information. It gives us snaps based on household, people with no people in the household 6 year older, family with just a married couple, families that have no children under 18, by disability status, by race and Hispanic or Latino origin, by work status. So that's where all those extraneous records come from. We have 118,000, but only 519 unique tracks. So how is it we're going to find exactly what we need? So there was one part that I skipped over in our slides. It's a principle called tidy data. And there are 3 main principles on knowing whether our data is tidy or not. And that is here, that each variable forms a column, each observation forms a row, and each value must have its own cell. It may seem very intuitive, like and obvious, but you'll see that that's not always the case. But is our data tidy? Yes, we're using the Tidy Census Tidy Census package. So by default, our data is returned to us as tidy data. So we don't even have to worry about step 2 for this particular example. So let's do some transformation and exploratory data analysis. Like I mentioned, we have 118,000 records, and then there's a lot of information that is not needed. And also our variable names are not human readable. So if you actually look at variable, you're looking at what is S2201C01006. I mean, I can guess that this is our table name, obviously, but I don't know what C01-006 is. So thankfully, the Tidy Census package includes a function called load variables, and we can specify that we are looking at an ACS5 subject table. So you will have to read more on the census documentation if you plan on working with census data in the future, but just know for right now that any table that starts with an S is called a subject table. And so we can specify specifically, like, get us the variables that belong in subject tables. So if we load V19, we can look at all the variables that are in subject tables. And you're like, oh, wow, there's still a lot of variables here. How are we going to know what we actually need? But there is a variable called name, which is this one, and we can filter it. We can actually filter based on the table that we need. So there's a package in the Tidyverse called Stringer, and it can detect a pattern. So we're going to pass in, remember that filter function that we used was one of the dplyr verbs. We can use it in conjunction with str_detect, because str_detect returns a logical, like true, false, and that is what filter is conditioned on. So filter conditions on logic. So we can pass in str_detect a name. So we're going to pass the name variable, and we're going to look for the pattern S2201. So if we run this, we know that these 228 variables are actually from the snap table. So this gets us a little bit closer to what we need. So if we actually just scroll through and read through the labels, we can easily find the ones that we need. So I went ahead and put here that the variable S22CO4-001 is the variable for food stamp. And that's the one that we want. That is the % household receiving food stamps. And which variable gives us the household income for the past 12 months? Well, we can do the same thing, just read through these labels. Like the IDE has a filter, and you can just type income, and you can see which one of these is the income variable that we need. It's really easy. So I'm going to go ahead and go into my main snap data set and filter just on these two variables. So now we have 1,038 variables, which makes a lot of sense because we have 519 census tracts and one variable and two variables. So that 138 makes a lot of sense. So we have a little bit of tidying I want to do for the purposes of plotting. So I want to transform my data from a long format to a wide format. So we don't need the margin of error, and we don't need name anymore. And so we're going to pivot our data from being looking like this to, we run this line, snap inc wide, having one record per tract. and with our census, with our SNAP percentages and our median income. But we wouldn't know that. So I think we still need to rename our variables, right? So there is a very convenient function in dplyr called rename. And all you need to do is quite literally put in your new name, the new name of your variable, and the old equals the old name, just like that. And now when we run that and look at it, we now have exactly the data that we need. Transformed data, our census tracts with our income, and with each census tract, the percentage of that tract that receives food stamps. And with a little plotting, we can see the relationship. We can see that this is skewed a little bit. So, you know, we have some outliers, people that make over $250,000. And you can easily see a minimum, maximum. So the minimum in our data set is about $14,000 and the maximum is $250,000. There's a little tidbit. So like, what does that actually mean? What's the median? And it can give you a summary. So there's actually a nice function in base R that if you have a continuous variable and you just need to know the descriptive statistics for it, you just run summary and it'll give you your minimum, your maximum, your median, your mean, first quartile, and your third quartile. So if you're familiar with that interquartile range, this is that information that you would need. So like I said, you can visualize the spread of a continuous variable by a categorical variable with the use of box plots, which consists of interquartile range, outliers, and whiskers. I'm going to skip this part for just for the time being, because we don't have a categorical variable, but I created one based on the federal poverty level thresholds. So I categorized the tracts based on their income and put them into different poverty thresholds. So you can see how a box plot is used. And then I'm going to skip over the correlation just for the sake of time to exemplify the use of correlation. You can see what is actually correlated. And I'm actually going to just jump to the analysis part of our workshop. So we want to see our hypothesis again. Our hypothesis was, do people that live in tracts with higher income receive lower percentages of food stamps? So the first thing I'm going to do is I'm going to take that information and I'm going to make it a scatter plot. So we have our SNAP Inc. wide, this transform data that we pivoted in earlier steps. And we have our income on the x-axis and we have the percentage of food stamps on the y-axis. And we're going to use our geom point. Okay, so this is a nice little trend that we're seeing here. This kind of looks like our histogram a little bit. We can see that there's some skewness, or some right tail skewness. And for those of you, a little quick reminder, we have skew, which means that it's not perfectly centered. So, you can have left or right tail skewed. So how do we need to handle this? So this clearly shows a negative relationship between income and the proportion of residents on food stamps. However, there's a strong tail on the x-axis leaning towards the right. So we can fix this with a log transformation. So a transformation, very briefly, is when you have, you replace each variable in x with log of x. And doing so usually helps your skew data become less skewed and make patterns a little bit more visible. There are different kinds of transformations you can do, like root, square root, cube root, for example. but this is where a little bit of stats background for data scientists comes in handy. So what I'm going to do is that same ggplot, but instead of putting on the x-axis income, I'm going to actually put log 10 of income. So I'm going to go ahead and do that transformation directly in my ggplot call. And then on top of it, I'm going to add a smoothing line, a regression line. So that smoother on top. And a smoother helps us see a trend a little bit more clearly. So I made sure to make certain that the x-axis is actually the log of household income. So it makes it, and this is the percentage on food stamps. So you can see our trend a little bit easier. So let's see if this relationship is actually statistically significant. This is where the model comes in. We're not doing any machine learning, but we'll do a little bit of statistical analysis, inferential statistical analysis, using the LM. All right, so I'll quickly wrap this up. We are running short on time, but essentially the LM function is linear model. And it takes an equation that looks something like this. So you have your outcome variable, which is percentage of food stamps. And you have your tilde, which is technically the equal sign, but we can't use equal sign in the formula syntax of a linear model in R. So P food stamps, percentage on food stamps, as it relates to income. So income is going to be our independent variable. And we obviously have to specify our data. So if we run that and we run a summary on that, we can see that if you're aware of p-values, that our p-value is less than 0.05. So it is statistically significant. So we will reject our null hypothesis, that meaning that there is no relationship. But essentially, that p-value lets us know that it is evidence against our null hypothesis, and the smaller the p-value, the stronger the evidence that you should reject that null hypothesis. So finally, the communication step of our data science pipeline. So after we've done all this, all I have to really do is knit this document. And I made a little note in part 5 that says, this entire analysis was written in an R flavored version of Markdown called R Markdown. And you can read it using the knitter package. You can produce this analysis as an HTML. And then you can visualize it. For bonus points, I added a little map to visualize our proportion on food stamps. So if you just hit this knit button, you'll see in the console on the left-hand side that it's running, it's doing a job, and there's API calls involved. The more calls that you have and the more processing, the little bit longer it's going to take. So it's going to do these little API calls. But this is one of the beauties of our Markdown, and that it gets us to quickly wrap up all of our analysis that we've done and make it reproducible and make it presentable to our stakeholders. So I could actually just pass this document, this HTML document, on to my boss or whomever asked for this analysis. And if you can see my screen, this is what you get. So that entire code, I hope you can see my screen. Can you guys see my screen? Somebody say yes or no. Let me open in browser just in case. Can you see my screen now?
Yes, we can see your screen.
Okay, thank you. All right. So, so all of those steps that we went through, going through the dplyr verbs, it actually shows us some code chunks. It shows us a little bit of output from our data table. Each of the notes that I wrote, with the italicizing and code chunks and backticks, that's all marked down. Putting things numbered as numbered sections and then our output. So I could hand this off. I mean, realistically speaking, my stakeholders don't really need to see the code, but they would want to know what questions I pose, my analysis process, my thought process, and the plots. So we can see all the plots that we generated. And we can see that box plot that I skipped over, and the correlation plot that I went over. I highly recommend that you do that on your own time. And then at the bottom, we have a little map. So we can see, and because this is HTML and interactive, I can actually highlight and zoom in and get information on that tract. It's really freaking cool, in my opinion. So anyways, I'm going to wrap up, but I want to thank you all. And here are the resources for a lot of the things that I mentioned during my talk. And I can't not give a plug to Our Ladies Miami. I am an organizer. So if you are actively trying to learn R, I highly recommend that you follow us on Twitter and Instagram and Meetup, the Meetup app, because we're quite active. We do host a lot of experienced individuals that use R and data science that will present on a topic. So anyways, I thank you all so very much. I know there's closing remarks right now, so I will bid you all farewell and thank you again. And feel free to shoot me an email if you have any questions.